right, hey, good afternoon, everyone. My name is Todd Schechter, and on behalf of the Community Exchange Program Committee, welcome to this afternoon's session titled Bridging Security and Research, presented by Llewellyn Fernandez from Northwestern University. This afternoon, we will explore the intersection of research advancement and regulatory compliance. As our researchers strive to push the boundaries of discovery, they often encounter a series of security and compliance controls that can feel more like obstacles than facilitators. Our focus today is on empowering information technology teams to enforce security policies effectively without impeding the pace of research. We will explore practical, researcher-centered strategies that integrate security into the research culture through direct engagement, local IT partnerships, and collaboration with institutional offices. Please join me in welcoming our presenter, Llewellyn Fernandez from Northwestern University.
Hello, everyone. Can you hear me? So used to doing this with the Zoom. Am I audible? All right. So thank you all for having me here today. I am Llewellyn Fernandez, and about this talk, earlier a little bit about myself. I was a data manager involved in research for about 4 years. And my first introduction to research was me onboarding with my team. I get a laptop, and I realized none of the USB ports work. And I go reach out to my PI and said, hey, why aren't the USB ports working? He's like, oh, you'll learn about it through our onboarding session. Through that entire process, I eventually learned that, okay, these are security controls that are applied to this laptop because of the kind of data I was going to work with. And it was PHI, PII kind of data sets, but that was my viewpoint of, as a data manager involved in research, what is it that it takes to conduct research with sensitive data. With 4 years of experience working on projects that involved sensitive data, I then transitioned to an IT role where I am now part of a centralized IT team that helps researchers with sensitive data. So, which is why the slide says I help researchers focus on research. Now, why am I here having this conversation or talking about this topic today is because, as most of us, if not all of us already know, that research today is not the same as it was, I would say, 10 years or 15 years ago. It isn't just researchers with their laptops looking at data and running their experiments and conducting their research. There's high-performance computing. There is a lot of data that is being generated. There's a lot of data that is being processed in real time, so the demands have increased. Some of the points of the slides that I've mentioned is 88% of the institutions now use cloud for research. And at least this article is from CDW that talks about it is not just some research, but a quarter of their research has now been moved to the cloud. But with that, the cloud being such a vast system that it is, securing something like that can take a lot of effort. Similarly, with all the changing compliance requirements, what we see that EDUCAUSE had this article 2 years ago, which said, it was a year ago, which said that it was just about 8 to 13% of the institutions that maybe are fully compliant with CMMC level 2. And something that we learn here today is that this is not just something that the researchers need to worry about. It is also our responsibility and our duty to make sure that they have the right environments and they have the right tools to conduct their research. So most of us are familiar with the research life cycle. I've taught this topic with this exact same slide for, I believe, around 8 to 10 workshops already, and I use this graph almost everywhere. Research ideally starts at the planning stage, where you start writing, PIs will start writing their grant applications. Once it's approved, they will then either start collecting or generating their data. Eventually, they will start processing it. And this is the fun stage that I was involved in, which was the collection and the processing stage, where I got to look at all the data sets that I was working on, and I got to clean them, I got to run analysis. It's a lot of fun. And then eventually they come to the publishing and the archival stage. Something that I learned after joining Northwestern is that, and being part of Central IT, is that security and compliance, they exist, like these requirements exist in each and every state of this process. As a researcher, I was happy that I had a nice laptop that I could install fancy software on. Actually, I could not. I had to request IT to get software installed on there. And I could run some really, really good analysis softwares that I wanted to do. But from the other part of the landscape, as an IT professional, you're worried that, okay, is that student really using the laptop the way they're supposed to use it? It's no longer coming into work, logging into a desktop. We have researchers now sitting at coffee shops, connecting to their Wi-Fi, and using that laptop for research. So security exists in every stage. When we talk about the planning stage, it is about, in the planning stage, we talk about the grants and data use requirements that come into place. When the data is being collected, we're talking about the vulnerability of this data actively being generated, right? It's being either it's coming through instruments or it's coming through surveys with different kinds of research. In the processing stage, they need heavy compute. That is another requirement that we need to secure. In the publishing step, it's important that only the data that needs to be made public is what's made public. So that is where IT needs to be involved. The research and data computing team, we are involved with researchers to ensure that only the data that is allowed to be published is published. And eventually with archival, that researchers are happy that yes, their data got published, their papers are now being reviewed, everything's great. But after that, there are often data sets that need to be audit ready for certain years, and they need to be archived. That is not just findable, but that can also make sense for the next round of students who are now part of the team, and not the previous student who is now graduated and gone and has a very unique way of storing the data. So ideally, and I've put ideally in bold, researchers will come to us when they are in the planning stage, and that is something that we would like them to do, because we can get started right from the beginning, ensuring that the storage platforms, the compute platforms, and the collaboration platforms are all done in a compliant way. But normally what we do realize is that with the ongoing changing requirements, with new regulatory requirements coming into play, researchers are now at a point where they're coming to us where data is either already being collected or they are already in the stage where data is being processed. A clear example of this is the dbGaP data sets that now require NIST 800-171 compliance. And my team and other teams at Northwestern have been working with each one of them to now transition their entire workflow, research workflow, from what used to be, oh, we just log into our HPC cluster and run our analysis. But now we can no longer do that. We now have to change our entire workflow. My personal laptop is not going to work anymore. My PI now needs to purchase laptops and have IT install security software on there. So all of these changes, all of these requirements can be really hindrances, if you think about it, for research. And that is something that we have had to deal with the grunt of it. Frameworks like ITAR and CMMC, they require FIPS validated encryption, meaning if any group has some data sitting in Dropbox or like Slack, which we have seen that researchers do, none of these are now approved, and they have to go with the process of migrating all of that data to a new platform. So these are things that that research now is having to deal with, not just the researchers themselves, but IT and the institutional offices, right? So workflows are being adapted and adjusted, and mid-project, the compliance requirements are changing, which is causing interruption. And the way this is impacting research is that very simple diagram, which was just 5 stages, has now become this complicated process where they are now planning, collecting, processing. Okay, let's take a pause, let's plan again, let's change our practices. Maybe some of the students may not even be eligible to work with this data set, make some difficult decisions, all while time is being passed. And in some cases, you have a project runway with funding that may only last for a certain period. You will have students that you can pay only up until a certain period of time. So all of this is now impacted because of the changes that are happening. And how are we dealing with this, right? As I mentioned earlier, the ideal scenario is engagement from the start, where they come to us, they work with us, we set things up for them, and we review and monitor them for the initial stages of the research. We make sure that security is embedded into the design of the research, and that there is a responsibility that we realize it's between the three parties, right? It is a research group, it is IT, and it is the institutional offices. So I sort of when I have been working at Northwestern and been working with researchers, research groups, students, and my colleagues and I have identified, like, these are three areas that we see that we start facing security challenges. Those are the timings of when these implications or security requirements come into place, the changes that come with them, and then most importantly, how visible are our existing solutions to the researchers who need help. So when I was thinking about this topic for presenting to this talk, I used the word bridging security and research because I was once traveling, taking the water taxi in Chicago, and I noticed the Lake Street Bridge. And it's a very unique piece of architecture because that bridge is not only for cars, but it serves multiple purposes. You have you have the L train that goes above it, you have the cars that drive through, you have pedestrians walking, you have bikes going there. And this sort of came to me when I was preparing for this presentation. And our job as IT professionals in higher education, working towards building compliant requirements and dealing with the new security requirements that are coming down on institution is not just one shop solution. It is us having to work with a plethora of solutions, and this analogy sort of helps me navigate some of these challenges, which are the bridges that we build, right, to help researchers meet compliance need to be like a shared responsibility model, and they need to work, for example, for the train, right? The infrastructure needs to work for, the solutions need to be scalable, right? And I'll walk through some examples in the further slides. The cars are, some research groups will have funding, right? They can pay either external contractors who can work with IT to build custom and unique solutions that meet their needs. But then there are also the students. Researchers is not just the PIs doing their work or big research groups that are part of the institution, but it's also the grad students, it is the PhD students, the postdocs who are also conducting their independent research where resources are limited. And security compliances are not any different for them. It is all the same. If they want to work with that kind of data, they need to meet compliance. So as an organization, how do we provide for the needs of these varied type of requests that come by? Part of it is we can build highly controlled environments. We have seen a lot of institutions do that. That is, we call them secure data enclaves, where it is a secure infrastructure that can be used by a select group of researchers who can afford it, who can pay for the cost that comes with running such systems. Then there are moderately controlled environments that, let's say, secure virtual machines that a researcher can use, and this can be open not just for PIs, but also to students. And then just accessible baseline environments. For example, having compliant softwares or having compliant for transcription is one example where students want to do some text analysis and they need to transcribe sensitive data. They should have accessible softwares to do so. But all of this is important, and IT can work really hard to put together solutions that meet all of these requirements, but none of it will be valuable if it is not visible to researchers. And for our group and for our researchers, for our team, this has been one of our driving forces that we have been working really, really hard to increase our visibility. Because earlier just today I heard another talk, but I've heard this point come up multiple times. Within a research group, you have the PI that gets the grant, that initializes the research. But the grunt work, the work of collecting and doing all of the analysis, that is mostly done by students. It's mostly done by grad students or part of the research team who may not have visibility into the resources that are present at the university. As I mentioned earlier, when I joined that university as a data manager, my first question was, why don't my ports work? But that was a compliance document, and I actually inadvertently triggered training, not just for me, but also my PI, because apparently he was supposed to let me know why the ports don't work, and he did not. But the point is, visibility is important, right? Researchers will seek out solutions because they want to get their research done. They will contact individual contractors. They will pay them the money because they have it from their grant. They will get the research going. Now, this is something that, like I mentioned, our group is working on, and why this topic is so important today. And it is a responsibility not just for our IT offices alone, but for an institution as a whole, to make sure that all the time, effort, and money that gets put into ensuring that we are being compliant, it is also being visible. It's also visible to our researchers. I'm going to talk about some case studies going forward about the three. I'm going to take three examples. I've put together three examples, one for each kind of solution that I spoke about earlier, that my team dealt with in the past 2 years since I've been here, and one of them, so the first scenario that we're going to talk about is this research lab where it's one PI with 12 researchers, some internal, some external. They had six data sets. Each data set was governed by a distinct data use agreement. Now, this lab, when he initially started the research, they worked with their local IT to build a server that had compute and storage. So all of it was on this one server that this local IT managed. The students had managed laptops that they would use to access this environment, perform their analysis. The data never left this server. Granular permissions were maintained at a folder level by this IT person. So what happened was that server is now really, really old. It's about its end of life. The local IT individual is nervous that it may fail and there is no backup, and the data sitting on there requires heavy compliance. So they reached out to my team, and we first worked in breaking down this problem, identifying, reviewing the DUAs with the team members, with the PI, understanding what each of the requirement was, only for us to find out one of the data sets requires NIST SP 853 compliance. That was like, we had to take a pause. I said, okay, let's keep this data set aside for now. We looked at what the constraints were. There were external users that were part of this project, and we had to work with making sure that all of them had access using the resources that were already available to us. This solution was built a while ago, and with today's environment, rebuilding a server like this would not really meet the requirements that exist today. 12 years ago, this worked. Today, it does not. So the approach that we took with this one was we worked with the researchers, as I mentioned, to map each data set to the appropriate controls, and we identified what each requirement would be for each data sets. We used on-prem storage for storing some of the data sets which met the security requirements. And for the compute, we recommended that they use virtual machines that were secured and that could be managed by the local IT. For the data set that required NIST, We then had the PI negotiate, talk to the Office for Research. So this was, like I mentioned earlier, a collaborative approach, not just with research IT, but also with the institutional offices, with the PI, and the data sponsor that got them the data set to then come up with a solution. They renegotiated it down to NIST 800-171, which we then migrated into one of our enclave environments. We helped document each and every research flow, identified every user that would access the system, drew data flow diagrams for them. It was a lot of work. This project spanned almost 2 months, 2 to 3 months of just working with each lab member, understanding their workflow, and building a solution that worked for them. So this is like that, but all the solutions that we deployed here were that were already existing at Northwestern that we were able to use. So the takeaway from here is complex environments will rarely map to a single solution. For each one of the DUAs, it wasn't that, okay, you can just store all of it in one storage medium and it'll work. We had to adapt to each one of the requirements. The second scenario is the car analogy, which is more of a tailored approach. This is an NIH-funded project that had EHR data. And this data set included 30,000 patient records across 20 hospitals from 4 different states. The moment I remember this call, I remember being on this call, and the moment they described this solution to us, me and my colleague were like, even though we were on Zoom, we had this look for each other, said, okay, this one's going to be a difficult one. And the first thing we did was, like, they wanted to host all of this data, and it wasn't meant to be public, but they were meant to be data stewards, where partnering research groups could then submit requests and get access to this data, but only within that secure environment, analyze the data set, get their findings, and then log out. So this was a complex solution that needed to be built. And the fact that data was coming not only from multiple states, that means the requirements got complex, but in addition to that, the users that were going to come in were also going to be from different states. So that also increased the complexity. And the fact that this was EHR, which meant that HIPAA also applied. So our approach for this one is, fortunately, this research group had funding, and we were able to work with local IT, work with the research group to help them leverage a cloud infrastructure where they built I believe they're still working with the contractors to build a custom solution that will be completely hosted in the cloud, and it'll be a front end that will leverage Jupyter notebooks that the researchers can come log in, get authenticated, access the data sets, and along with that, the lab members will be trained to manage not just the overall system, but at least the users that come in. So the outcome of this one was they were able to build a secure, scalable environment to deploy this data set for access. And this is one of those examples where the solution could be tailored because there was funding. The next example that I am going to go to is the one where there is no funding. This was a PhD student who reached out to us, a really ambitious student that I personally worked with. They had put in a request to the Department of Corrections to get access to this data set. With the strong application, they were approved, only to realize that they now have to fill out a data security management plan. They had no idea what that was. Through our public-facing websites, and also attending one of our workshops, they got in contact with our team and they reached out to us. They said, I don't know what's going on. This is for my thesis. I need to perform an analysis with this data set. How do I fill out this form? His original request wasn't even, I need to meet security compliance. His original request was, I need help filling out this form. I found out that your team can help with that. What should I do? So, well, the challenge was, the student was using a personal device, of course. He did not have a managed endpoint. The compliance required secure storage and secure compute, secure compute as well. The challenges, the constraints were no funding available at the time, and I'm saying at the time with a reason. The student did not have technical experience. While he was getting his PhD, he was also learning R. So that was another thing. And he needed this quickly because he had to perform his analysis and write his paper. So what we did was initially we solved the first problem, which was we guided him through the data management plan. We coordinated with the institutional offices, worked with the security office, worked with local, we also contacted local IT to check to see if there are any scholarships or if there are anything that that local ID provides for students that are working with this, because they're working with this kind of data sets. And we were able to set up a no-cost solution for the student with a secure VM. The data was transferred using SFTP. The storage was restricted only to the VM itself, with no data egress could be permitted. And what we were able to also do was negotiate with local IT to sort of buy into our on-prem storage for the student for this limited period of time, where he could get the data stored and work with his work on his analysis. So this is an example where even with no funding, working with the student, understanding what their requirements are, and making sure that we have solutions that can not only support the larger groups that have the funding to do so, but also the students, because research is not just limited to, like I mentioned, big groups alone. So in summary, what has worked for us and our team? Now, these parts I hold really close to us. These topics are really close to us and our team because we have seen results from these approaches. One of which is making support visible. We spend a lot of time, and that, like when I say my team, my department spends a lot of time writing a lot of documentation and making sure it is publicly available and findable by researchers. We conduct a lot of workshops that is across my department, but my team alone, we've conducted roughly about 200 hours worth of workshop content in the past 2 years. So we make sure that we are getting ourselves in front of the researchers. We write how-to guidance documents that are accessible by researchers and students. We have worked towards building relationships across IT. We've spent time presenting our services and what we do as a department to other local IT. Being part of centralized IT, we feel like there is that disconnect, and we've spent that time building those relationships so that we get to hear if there are researchers. We've had instances where local IT has reached out to us that, hey, there's this researcher who needs help, can your team help? And that is the best part of this job, that I feel that getting to help these researchers, even if they come in, like for example, if they come to my team, which is the data management team, and that is not something that we may be able to help with, but once they come through the door, we can get them to the right person and get them the help they need. And that to me is really important, because as I mentioned, if there is no visibility and they do not know that help exists, they will not know that they can ask for it. In addition to that, the way we do our consultative support we follow a slightly different model. For example, we don't treat tickets as a transactional interaction where we worry, okay, we need to close this ticket really quickly. We'll make sure that we are ensuring that the user has what they need, but that only comes by the nature of the work that we do. We give them enough time to follow up. We'll reach out to them, ensure that they have what they need. We have offered to work with research groups by providing customized workshops and presentations tailored to the data that they have in their research. I recently conducted a workshop where I helped a research group move around 6 terabytes of research data over almost 12 years from Dropbox to our on-prem storage. It took a while, but in that process of like a month of transfers, I was able to talk to each and every one of the research group members about data security, data management practices. What I identified was, okay, there was certain sensitive data that they had that was also in Dropbox. We made sure that was moved to the right location. We made sure that, because that group was able to reach out to us for one problem, we were able to identify 3 others and help that group get to a much better security posture. So these efforts that our group has been putting has really helped researchers recognize that support exists and security is not just a tax on their time. It is something that they need to take seriously, and it's not a complete burden on themselves. They have help and they know how to get it. With that, I end my presentation. I am happy to take any questions if there are. Thank you. Oh, I finished already. Yes.
Excuse me, folks, if you have questions, if you wouldn't mind coming up to the microphones, that would be awesome. Thank you, thank you.
You spoke a lot about in your presentation helping them you're providing for them secure, environments. A lot of that had to do with hardware, setup, storage, compute, things to that effect, cloud environments. A lot of this research is being done on applications that they're either writing or were written by some other PI perhaps and passed along to them. Do you guys spend or offer any services around helping them write more secure applications or taking those applications and making sure that they're more secure?
Yes. Our team also helps groups review DOAs and security plans, and also we provide support where in the initial stages of grant writing, researchers can reach out to us and we can provide support in terms of what storage solutions exist, and if they don't, what approaches we could take. So that's writing support is also something that we provide. Yes.
Yeah, thank you very much. Excellent presentation. I'm wondering, if you're encouraging units or individuals to proactively contact your team, and to get these things going before their projects, so that way you can have a good plan based on that. And I'm wondering if this was to be adopted by units across Northwestern, perhaps a majority of those doing research on campus, at least research that would be applicable to these concepts. Are you concerned that you might be overloaded with people reaching out to you proactively, or would it actually be less work because you wouldn't be playing catch up when things go wrong later on? Thank you.
That's an excellent question, and I didn't put it on the slide, but I can share some metrics that from my group. So we have 5 of us at my team, but our department is big enough. But my team of 5, we handle data storage, data transfers, and data security. So we do an average of 450 tickets per year. That is roughly helping around 300 users. In fiscal year 2026, which started September, we've already seen 358 tickets, and many of these are not issue-related tickets. These are people requesting help and support as well. We've done consultations, the consultations that I showed 3 examples of. We've done 70 of those. We do an average of 70 of those every year, with 65 unique groups reaching out to us. I already mentioned 250 hours of workshops. And for our on-prem storage, my team manages around 1.3 petabytes of data that is being accessed by 1,500 people. And for transfers, we use Globus. And for last year, we saw around 101,000 transfers. To get to your question, yes, we are busy a lot. We have times where we find ourselves, but this group works in a really cohesive way where we divide our time from support versus projects. As I mentioned, a lot of these services are like managing the on-prem storage, supporting users. That part comes from support. But there is a lot of projects that we are also doing that is automating some of our existing appliance systems where we can buy ourselves some time to, and to us, I know it is always that concern, would we have enough people to help the researchers with the influx of requests that come in? But we do manage enough metrics, or we track metrics within the team that helps us make that case, right, to leadership that we need the help, or we need more time, which eventually translates to we need more people. And but the brighter side is because that visibility has improved, we have a lot more people coming to us, but it is also that communication that's happening between researchers. We've had, so that part is the benefit from, even though there's going to be an influx of tickets coming in or requests coming in, we get to know more about what's happening in research, because for a very long time, central IT was sort of disconnected from research itself. My colleague just spent the last month physically visiting labs. She explained to us that she had fun going through the process. She had to enter a clean room, but we have become more ingrained in research that we can now advocate to leadership on behalf of researchers, that we learn, okay, this is what we can get for them next. This is the avenues that we can approach. These are the possible solutions that we can put together. Because I recently attended an Internet 2 talk where they spoke about the enclave model for sensitive data. How many enclaves are you going to build? Is it going to scale for each and every research type? Being engaged with researchers is what gets us those answers. Any more questions? All right, I think we'll end there. If you have any more questions, I'll be around. You can always ask me.